Hello and welcome back to Math Class with Mr. Kerr. Today we're going to be working on our first unit in 8th grade, and we're going to be talking about square roots. We're going to be talking about perfect squares and then also estimating square roots that aren't perfect squares. So first of all, we'll start with the most basic thing. What is the square root symbol? So this is our square root symbol. Kind of looks like a long division symbol with a little, maybe like a number 7 in front of it, but just like this, or down here you can see another example of it. So that's the symbol, and the way we would say that is the square root. So what is a square root? What does that mean? When we see a square root, we're asking ourselves this question: what number multiplied to itself is the number inside the square root? So for example, let's look at this. First of all, we would say this is the square root of 25. So the square root of 25 is what number multiplied to itself is 25. So what number can I multiply with itself to make 25? So the square root is 5, because 5 times 5 is 25. The square root of 4, what number can I multiply together with itself to make 4? So what number times itself is 4? 2 times 2 is 4, so the square root is 2. All right, now we're going to list all the perfect squares here. Right now would be a good time for you to maybe pause the video and go through and see if you could answer these on your own. Find all these perfect squares. So I'll give you a second to pause the video, go through, see if you can answer them on your own, and then start the video back up and you can see all the perfect squares. So square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. Square root of 144 is 12. So those are all your perfect squares. Eventually you should have these memorized. For now, these notes will be very helpful when you're doing your homework until you have these all memorized. So those are all our perfect square roots. Now let's look at an estimation. We're not going to be real precise here for now. We're just going to be basically saying what whole number it's closest to. So here we're asked the square root of 14. So when we do this, we think through, okay, which perfect squares is this closest to? 14 is between, the square root of 14 is between the square root of 9. What perfect squares is it between? Square root of 9 and square root of 16. And then is 14 closer to 9 or is it closer to 16? It's only 2 away from 16. It's 5 away from 9. So it's closest to the square root of 16. Therefore, we could estimate this as the square root of 16 or 4. And these, if you're not familiar with this, these squiggly lines, it's not an equal sign, but it's kind of like an estimation or about. It means like about 4. All right, so the square root of 65. So let's look through all our perfect squares here. Let me move this up. So what perfect squares does 65 fall between? It's bigger than this, so 64 and 81. So 65 is between the square root of 64 and the square root of 81. It's obviously closest to 64. It's just one different or one more than that. So closest to 64. So the square root of 65 is between the square root of 64 and the square root of 81, but it is closest to the square root of 64. Therefore, we would say this is about the square root of 64, or 8. Square root of 23 is between the square root of 16 and the square root of 25, but it is closest to, so it's 2 away from here, and it's more than 2 away from here, so that's closest to the square root of 25, or it's about the square root of 25, or 5. Now here's one little kind of note to remember. Non-perfect squares, so all these are non-perfect squares because they're not one from the list above. Non-perfect square roots are numbers that go on forever without repeating. So if you took a calculator and checked what the square root of 14 is, or the square root of 65, or any that's not a perfect square, you would see that it's you'll get a decimal, and obviously the calculator can't show it going on forever, but you'll get a decimal that goes on till the end of the calculator, and it doesn't repeat. It's not like 4444 or 121212. It doesn't repeat. We call these numbers irrational numbers. So non-perfect squares are called irrational numbers, which means it's a number, a decimal number, that goes on forever, that doesn't repeat. So that's an important thing to remember. Non-perfect squares are irrational. All right, thanks again for spending time in math class with Mr. Currat. I look forward to talking to you again soon.